Hi, I'm Papia. In this problem, we have to find the missing value for the given radioactive isotope. And the missing value is the initial quantity when the half-life is given to us and the amount after 1,000 years. So notice that this is a radioactive decay model that we're using. So what is a radioactive decay model? It is y equals a times e to the power negative bt. So using this model, we have to figure out the initial quantity. Now note that the initial quantity is that variable a. So we are trying to find what is a. Now let's see what is given to us so that we can plug everything in the equation and can we solve for a. Well, y is the final amount. And we have that amount after 1,000 years is 2 grams. So it's given to us that y is the amount after 1,000 years. So y is 2 when the time t is 1,000. So t is given, y is given. A is of course what we have to find. That's the initial quantity. And that's it, right? Well, look, there is another variable. There's a b, which is also not known. But we have some information here, this half-life. So you have to use this information to first figure out the b. Then we will have all the other variables we can plug in and figure out a. So the very first step is find b. Okay, so let's see what's given to us. We know that half-life is 5715 years. What does that mean? That means if you start with the quantity c, so if initial amount of the isotope was c, half-life means when that amount has reduced to half. Okay, and the time it took to reduce it to have that amount is 5715. So if this is the initial amount, then the final amount is c over 2 when time was 5715. So that's given to us. All right, so let's see if we can plug this information in that model and see what we get. So left hand side is c over 2. Right hand side, a is the initial amount. So this is a. So plug in c for a. E to the power negative b times t is given 5715. Okay, so can we solve for b? Even though there is another variable here? Yes, because this c actually will cancel out. So we'll have 1/2 is equal to e to the power negative 5715b. Well, let's solve for b. And this is an exponential equation, so you can just take natural log both sides. So let's do that. So we have natural log of 1/2 is equal to, you know, when you take natural log of e, they cancel and you just get the exponent. So it'll be negative 5715b. So b is equal to natural log of 1/2 divided by negative 5715. All right, so we have the value that we wanted, the first one. And then using that, we can find our missing quantity here. So let's use this value in the model one more time. Okay. So this is part 2. This is when we are finding a, the initial quantity. So take the equation one more time. Let's see what is given. Y is 2 equal to a is unknown, e to the power negative, b is right here. So plug the whole thing in. Natural log of 1/2 divided by negative 5715 T is 1000. So times 1000. Okay, figure out A. So divide by this entire expression, the exponential expression. So A is equal to 2 divided by e to the power negative natural log of 1/2 over negative 5715 times 1000. So let's plug that in the calculator and figure out what A is. So it is 2 divided by e to the power negative of natural log of 1/2 divided by negative 5715 times 1000 is approximately 2.26. Therefore, the initial quantity for this isotope was 2.26 gram. And we are done. Thank you.